Welcome back to another gray and drizzly day in Thailand. The last few videos I've been playing with rockets a lot, but now I'm making my way back to the electric scooter. I've actually been working on the software in the tablet a bit, but from the hardware standpoint, I've gone back and I've redesigned, or I'm in the process of redesigning most of this master control circuit. But I'm also focusing on this thing, the bus bar. For those of you who have been with me for a while, you'll know that I spent an awful lot of time and energy on trying to figure out the best way to make a bus bar to have a bunch of wires all coming up to us the same electrical point, make it strong, make it electrically solid with good mounting points and everything. And I'm also restricted by the parts that I can buy here in Thailand, and the whole thing has just been a mess. This is what I ended up with, but ever since that day I've not been happy with it. So the moral of the story for today is it's okay to go back and reevaluate something you've done, even if you put a lot of time and energy into it, and scrap it and go in another direction. Never try and limit yourself and be stuck with something that you're not happy with. So, today we're going to talk about bus bars. This is the old one. I've got 4 mounting points here, and I've got this kludged up jumpery thing over here with the spray rubber and the dodgy electrical connections, and it's just I can't bring myself to put it into the bike. So I had a rethink. Let me clear this out of the way and we'll move to the next step. So the last time I was in Bangkok, I wandered around the electronics area, the neighborhood called Ban Mo. I'm always on the lookout for cool little bits of electronics and something that I might see and catch my eye and use, or say, oh, I don't need it now, but I could use it in the future. So I built up a nice little stockpile of parts. And this was one of them. With the bus bar situation, I've been looking for alternatives. Now I came across this. It's apparently maybe a brass bar, or it's plated aluminum or plated copper with screws in it. And I believe the way it's designed is that you're supposed to put a bare wire end into the hole here, and then you tighten down the screw, and then you have electrical connections. It's meant to mount on here with a couple of screws, and it's a standalone unit. But what I really need is a bus bar, similar story, but with a positive and a negative side. I don't want to have the complexity of 2 pieces flapping around like this. So if I had a system that had 2 bus bars like this together with an electrical barrier here, so there'd be no potential to short, electrically all isolated mounting points and screw points, so that would be really cool. So I thought, well, I've got a few minimal CAD skills and a 3D printer, so let's see what we can come up with. So let me take you there. Okay, I've taken the metal piece out of the bracket and came up with this. I did some measurements of the physical size, determined how I wanted to do my mounting, have a separator between the parts and a nice little compartment for this to fit into. I laid out a little sketch on paper with some dimensions, and then I put it in the CAD system. And I came up with this, printed out in about 25 minutes, which is pretty good. So what we've got is that this slides right in here, like that. And this one slides in like that. So this is a pretty good first approximation of what I'm looking for. And I even, in CAD, I wrote 60 volts DC minus, or 60 volts DC GND, and 60 volts DC plus. and of course the lettering didn't come out anywhere near right, and I used a red paint pen to paint across the top of those letters. But this is a good start. What I realized I needed is I want to bring the electrical protection up to this level because I don't need to have this part exposed. I want to have the barrier between the two metal bars raised up much higher. I want to have them separated more. In fact, separating the bracket from the rear wall, because of the size of the connectors I'm using, actually stick back a little farther. You can see this thing doesn't autofocus, so I can't say focus, you know what. So I need some extra clearance behind the bar. And otherwise, oh yeah, and I forgot to countersink the mounting holes for the screws right here that hold the brass parts in place. So, revision 2. And then what I also thought I would do, and this came from a suggestion from Abel, is actually use the capability of the printer to print a red bar around the positive side and a black bar around the negative side of the circuit. So I don't have to label it, it's just there. So I came up with this guy. So let's pop one of these in. So I'm now blocking it across the front. I've got the red on here, but I missed the fact that I needed to add the extra clearance behind, and my countersinks are good, although this base is a little thicker than it needs to be, so I will cut that down. This is a bit of a melty part from the start of the print, didn't start cleanly. So then we moved to the next one, which is this guy. And this is pretty much finished. I'm happy with this. It's a little narrow, a little thinner top to bottom, saves some print material. All the edges are rounded and chamfered. The mounting holes have a chamfer to protect them from sharp edges. There is sufficient clearance behind the metal strip for the connectors to fit, and the holes are properly countersunk. And this was all printed in one go using the capability of Fusion 360 and my printer. I was able to do a dual color print, this in much the same way that we did the Stormtrooper. For those of you who remember the Stormtrooper guy, the white and the black was printed in this at the same time as the print went forward, except this was a lot simpler. Well, simpler in concept. Lots of screaming and swearing and looking up really bad YouTube videos for how to define two different kinds of colors in Fusion 360. But what it takes is you basically want to define these as two different bodies, and then each body basically becomes an independent object that you can then save as an STL file, which you then give to the printer. And then the middle step is the Simplify 3D printing prep program, and you tell Simplify 3D for body number 1 I want it black, which means the right print head, and body number 2 is red, which is the left print head. And I had to they didn't drop into Simplify 3D cleanly in position. I had to drop the first one in, move it a little, drop the red in, and then manually move it millimeter by millimeter until it fit exactly into place. Then I said, okay, print. And this is the result. So I'm pretty happy about that. And this electrically is beautiful for the circuit. Mechanically, this is only printed still in fast mode, but it's really strong. It will mount well. It's self-identifying between the positive and the negative. and I'm just really pleased with the way that came out. So next step will be to update the main board, or the prototype board, with this and the new circuit that I designed, which is another level of complexity, which will help me avoid blowing up the JevQ again, fingers crossed. And so that I didn't have to have the motorbike in pieces in my room every time I wanted to work on it, I actually ordered a 60-volt power supply from China, which looks like this, which simulates the bike's battery. All I have to do is plug it in, switch it on, and I get 60 volts DC out of here. I put my prototype breadboard here, and the system is completely independent of the bike. And I can work on it to my heart's content until I'm very happy with it. So we're making progress mechanically and electrically, and let's just go from here. I'll catch you soon.